Astronomers have recently discovered the most massive stellar black hole in the Milky Way galaxy. This black hole is considered almost 33 times the mass of the Sun. But what if I tell you that it is just a tiny piece of the whole universe? Take a moment and look around yourself. Vast skies, deep oceans, mountains and deserts, they seem too big for us humans, but the reality is quite different. Imagine the whole universe as a picture. What if I say that our planet Earth is nothing but merely a blue dot in the whole picture? Now come out of your imagination, because we're gonna go on a vast journey of the solar system, starting from our planet Earth to the cold and icy edges of the Oort cloud, and then to interstellar space. Our planet Earth is 149 million kilometers away from the Sun, while the farthest planet, Neptune, is almost 6 billion kilometers away from it. The distance between the planets and stars within the solar system is extreme. We cannot measure it in normal units like feet or kilometers. That's why scientists have devised another unit called the astronomical unit, or AU, to measure these greater lengths. One astronomical unit is the equivalent of 150 million kilometers. To make things simple for you, let's take an example. If you're familiar with the Times Square ball, it is almost 3.7 meters in diameter. Consider this ball as the model of the Sun. Now, consider a small marble that is almost 1 centimeter in size and is placed 153 meters away from the model Sun. This would be the first planet, Mercury. Going ahead, Venus and Earth would both be the size of a ping pong ball. They would be at a distance of 198 meters and 396 meters from the Sun, respectively. Next comes Mars, which would be almost the size of a blueberry or 1.5 centimeters in diameter, situated at approximately 607 meters from the Times Square ball. Jupiter is a comparatively larger planet, and for this reason, we would represent it with a basketball. It is far from the model Sun, at almost 2 kilometers. Uranus and Neptune, the coldest and farthest planets from the Sun, would be represented as the size of a grapefruit, each 13 centimeters in diameter. Their distance is greatest, almost 7.6 kilometers for Uranus and 11.9 kilometers for Neptune. We are going to position our hypothetical planet 9 in our New York-sized solar system. As it is 5 to 10 times larger than Earth, we would consider it as the size of a small watermelon. The interesting part is the distance. In our representative model, Planet 9 would be at an astonishing distance of 40,000 to 80,000 kilometers from the Times Square ball. It would take 10,000 to 20,000 years to complete one orbit around the Sun. Just imagine, its orbit duration is longer than the entire history of human civilization. Okay, now let's continue our journey towards the boundary of the solar system, which is called the Oort cloud. The Oort cloud is like a shell made up of icy bodies that surround our solar system. It is extremely vast and dense with a three-dimensional structure. Millions of comets are born in this region. It is like a frozen wall surrounding the Sun and planets. This region is so immense and far out that it is nearly impossible to measure its extent. Considering its distance from the Sun, the inner edge of the Oort cloud is thought to be between 2,000 and 5,000 AU from the Sun. According to NASA, Voyager 1, which is one of the fastest spacecraft, traveling almost 1 million miles in a single day, will take 300 or more years to reach the inner boundary of the Oort cloud. In fact, it will take another 30,000 years to exit from it. But what's holding it together? It's the Sun's gravitational pull. Even at an extensive distance of 100,000 AU, the weak but significant force of the Sun prevents the icy objects in the Oort cloud from drifting away. When these slight forces of the Sun are disrupted by other nearby forces, they push the comets into the stronger forces of the Sun's gravitational pull. This results in the comets that occasionally visit our solar system. Scientists estimate that the Milky Way contains 100 to 400 billion stars like our Sun within it, and it is continuously evolving with 7 stars born every year, whereas in the whole observable universe, there are between 200 billion and 2 trillion galaxies. Now imagine how far it transcends if each galaxy contains billions of stars. It's impossible to understand the infinite space of our universe because most of it is, and it will most likely remain, unknown. See this picture? As Carl Sagan famously said, look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of. Every human being who ever was lived out their lives. Every hunter and forager, every hero and coward, every creator and destroyer in civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. Look up at the sky and think about the infinity of our universe. Yet here we are, a small but significant part of it trying to understand the size of the universe.